Yeah, so let's do a quick intro to Linux and some basic commands in Linux. So that will kind of trigger some learning within you, right? And you can do the rest of the follow-up learning by yourselves. I'll point you to some documentation and some stuff around Linux so that you can learn it. But anyways, I mean, you're not going to be Linux administrators, right? So don't worry too much about getting too deep into Linux, but I mean, it will help probably in future and long term. You may definitely delve deeper into Linux and understand more of Linux. That will definitely help. But I mean, at this point of learning curve, probably you don't need to go too deep into Linux and kind of see the depths of it. But right now, you just need to understand, how Linux works, right? So what are the different flavors of Linux and how you can use Linux commands in a very effective way. So that's the intent. So let me just pull up something. Just give me a second, please. Yeah. So what I'm going to do is a bit of theory, 10-15 minutes, just to give you a sense of, what a Linux operating system is, and some bit of history into Linux and shell scripting. Anyways, we're not going to go deep into shell scripting either, right? So this is how the agenda is. I mean, what is the introduction to Linux, brief history about Linux, what does the Linux file system looks like, and some of the common Linux commands, and let's also do a quick demo. Right? And for the demo's sake, what you can do is you can use a provisioned EC2 instance, or you can provision a new EC2 instance and you can use it. Or there is also a free browser-based Linux instance available on in the internet. You can use one of those. I'll show you how to use that in case if you don't have. But for those who are using Linux as your workstations, I mean, you don't have to worry about this. All right. So what is Linux or Unix, right? I mean, it's again an operating system. I'm sure all of you would have learned what an operating system in your college courses, in your college curriculum. So I'm not going to go too deep into what an operating system is. It's basically a collection of software plus hardware. So that's the software that runs on top of the hardware. That does a lot of things with respect to controlling the tasks that a computer perform. You can change the software without disassembling the computer and rewiring, right? You don't need to test the hardware. You just reload a software and it will start working. So the operating systems of the modern operating systems are quite compatible with a lot of hardware devices. And that's where if you see, you have Windows, you have Linux, you have Mac, right? And within Linux, there are a lot of flavors of operating system, right? So these are all, modern operating systems that I'm talking about, but there are also other legacy operating systems which are used by proprietary, vendors like IBM, right? So who uses their proprietary operating system that runs only on their hardware. Whereas the other operating systems that I was talking about can run on commoditized hardware, right? So what do you mean by commoditized, right? So when I say commoditized, it means that it is available and it is manufactured by, say, multiple vendors, right? Using a set of standards, using a set of globally accepted standards, right? So that's what is called commoditized, right? Like, for example, the electrical appliances that we use are commoditized, right? I mean, they can work with anything, right? So for example, you need a socket, correct? A plug to plug your appliances. So if the socket is commoditized, right? So there are multiple brands who manufacture these sockets using a standard, using the electrical standards, correct? So for a specific country. So that's what is a commoditized hardware. And what is an application? Application, all of us know what an app is. The software program that provides service for computer user. Right? And in this case, I mean, cannot act without permission from the operating system. right? So any application that you take has to interface with an operating system and make use of the computer peripherals such as your CPU, memory, disk, monitor, and so on and so forth, right? So that way, the operating system becomes the control layer, right? So that is the one which provides all of this, and without operating system, you won't be able to build applications either. So these are all some of the standard operating systems such as Windows, Linux, Mac OS. I'm not going to go deep. This is how it works, right? You have your hardware, the physical hardware, then the operating system, then the application, and then the user, right? So this is how it interacts. The user first interacts with the application, then application interacts with the operating system, then the operating system sends those commands to the hardware, and it basically makes use of the underlying hardware, right? And these are some of the common features, right? Such as process management. So there are multiple processes that are running. Interrupts, right? So all of us would have learned about interrupts in CPU and microprocessors, right? Memory management, how the memory is managed effectively, right? For example, if a program is using a lot of memory, or rather it's not efficiently using it, how will the memory get utilized, right? So such as garbage collection and all of that. So some of those are application related as well. File system, and I say file system, the underlying disk, right? Your hard disk or SSD or any file system that you are. Device drivers, you'll have devices manufacturers, hardware manufacturers from multiple, companies. So now there is going to be a driver that is needed, which can interact with that hardware. Networking, TCP/IP, UDP. You have a network interface, right? So the whole networking is taken care by operating system. Security, such as process or memory protection. Like if I run a user process, that's only restricted to that particular user, right? Other users cannot intrude into that memory space. Then input type, output. So these are some of the things. And what is Linux? It's just an operating system. What are the functions? It initializes the hardware. It keeps track of multiple programs running at the same time, right? And it provides an organized method. Okay, so now before Linux came in, Microsoft DOS was the dominated operating system. Mac was there, but it was quite expensive. Unix was much better. I mean, before Linux came in, it was Unix, right? Unix was the one that started, but it's much more expensive, right? Unix was also very expensive. So only for mini computers, for commercial operations, Unix was being used. But people were looking at some sort of a Unix-based operating system because of the powerful nature that Unix brought, to users, which is a lot more cheaper and which can run on PCs, the personal computers, right? All the operating systems such as Microsoft DOS, Apple, Mac, Unix were all proprietary, right? I mean, because the source code was protected, highly protected. No modification was possible without paying a high license fee. So that's when in 1984, Linux was invented. It was by a person called Linus Torvalds, right? So he invented Linux, inspired by Unix, and he built the Linux kernel as a clone of Unix, right? He's the one who first wrote that kernel. What is kernel? Kernel is like the core of Linux. So then GNU is type of a licensing that started in 1984 with a mission to develop a free Unix-like operating system. And Linux was the best fit as the kernel for GNU project. And eventually what happened was Linux was passed on to multiple interested developers throughout the internet because it was freely distributed. The source code was available and it was freely distributed. And it's basically a result of efforts by Linus Torvalds, right? So he's the person who invented it and passed it on to thousands of individuals. It's basically a kernel, right, combined with various software and compilers from GNU. It's basically it's a combination of different different small programs, right? So each program or each package is a package in Linux, right? So when you deal with Linux, you understand it. So you'll have to install packages in Linux. Okay, kernel is nothing but it's a combination of multiple softwares and compilers. It's a complete full-fledged operating system, and even you take Android, it's a flavor of Linux at the end of the day, correct? And it's a lightweight Linux used for mobile devices. And not only that, I mean, Linux is used in a lot of embedded devices, right? I was giving examples of car, correct? Connected cars, connected appliances. So they all use Linux in some form or shape or other, right? I mean, because it makes life very simple by taking a kernel of Linux, modifying the code, making it lightweight, and then using it for your own purposes. There are different distributions of Linux, such as Red Hat, Fedora, CentOS, SUSE Linux, Ubuntu, Debian, so on and so forth. Okay, and it's supported by big names in the industry, such as Amazon, IBM, Google, Sun, Oracle, HP, and so on and so forth, right? So pretty much you take even Microsoft supports Linux these days. How many distributions are there? So these are all the different types of distributions, but I think the most famous and popular ones are Red Hat, Debian, CentOS, Fedora, what else? SUSE. Yeah, so these are some of the most famous Ubuntu, right? So these are some of the most famous Linux distributions that are available in the world today, right? And you can pick up any of these, and some of these are available again as a free open source license. Some of these are like paid. Like for example, you take Red Hat. Red Hat has made a lot of advancements to the way Linux works, and also they support Linux, right? So the Red Hat Enterprise Linux (RHEL) is a supported Linux version. So you buy a license, and if there are issues, Red Hat will support the Linux. Okay, so that's how it is. And what is a Linux file system? It's basically a hierarchical directory structure, right? So the moment you say *nix, correct? So it means that it's either Unix or Linux, right? So one of these operating systems, right? But as I said, Linux is inspired from Unix, and they built the complete kernel similar to what is there in the Unix, right? So the entire Unix file system is a hierarchical directory structure. When I say hierarchical, it has multiple levels, right? Structure resembles an upside down tree, okay? Like an inverted tree, correct? It's like an upside down tree. Directories and collections are collections of files and other directories. Structure is recursive with many levels. Every directory has a parent except for the root directory. Root directory does not have a parent. Root is /, right? So in Linux, the forward slash that you see, it's the root. That's the root directory, except that every other directory has a parent. Many directories have children directories. Unlike Windows with multiple drives, multiple file systems, Unix system has only one file system. Okay, and there's a standard base called LSB that specifies the structure of the file system, like how you have, in fact, for NTFS, we have got some sort of allocation table, right? So here it's a Linux standard base. So this is an example of how the file system is represented in Linux. As I said, // is called the root. Always when you say root, go to root, it means that you will have to go to / bin /boot /etc /usr user /where /sbin. So these are all some of the standard directories that gets shipped along with Linux. Okay, it's like your if you go to Windows, you have your SQL and program files, right? Or SQL and Windows. So these are some of the standard directories that you have in Windows, correct? So similarly, in Linux also, these are some of the standard places, like /bin has all the programs, all the binaries, right? All the binary programs are here. Like CP is a command, right? Cat is a command, ls is a command. So each one is a program, as I said, right? I mean, Linux is the kernel is nothing but a combination of multiple packages and multiple small programs, right? So when you run ls, it's basically a command. The command has some functionality associated with it. Okay, so this is how it is represented. So it's an upside down tree, remember that. If you need help in Linux, so then you use a command called manual, right? You just give -k keyboard, it gives you a complete manual for the Linux command, right? You don't need to, I mean, if you don't need to like switch to browser, search for it, right? Linux itself gives you that. Okay, so now if you see this, so this is how the Linux system is managed, right? You see there's a hardware underneath, that's the bottommost layer. So then you have the kernel. So the kernel is the core, right? So the kernel is the one which manages the hardware resources for the rest of the system. So then you have file systems and device drivers. Of course, Linux also has got device drivers, right? So that's how when you plug in a new keyboard, and how is the new keyboard recognized? Through these device drivers. So then there's a shell, right? Shell is nothing but like the user interface, correct? In Windows, you have the Windows screen, the main screen. After you log in, you get the main screen, correct? The home screen. That is the Windows. But whereas in Linux, you have a shell, right? So mostly 90%, people use the shell, which is the terminal, or which is the shell, right? So want to log in and interact with Linux. On top of it, you give your user commands, right? But there are also Windows equivalent GUI, graphical user interface for Linux, right? Usually Linux graphical user interface is very limited. I mean, people do use, some of our students in this class are also using graphical user interface from Linux, from Ubuntu. Right? It also gives you some kind of a start menu, some sort of mouse experience, right? And it gives you some graphical interface. But majority, 90% of servers or systems use just a shell and user commands. That's it. Okay, they don't really go into the. Okay, this is the file system / as I said, etc home user. Within etc you have different password is used to replace to change your password. So then there's also home / home, which has multiple users, right? I mean, these are the different users created in the Linux operating system, not by default. I mean, you can go ahead and create. So there will be a root user, right? Over and above that, you can add more. Root user is nothing but admin user, right? Yeah. So that's how the whole file system is structured, right? All the files are named by naming each containing directory starting at the root. This is known as the path name, right? So for example, if you want to know what is the full path of A, then it is /home / Neil /B or A. That's how the files are named, /home /Neil /B. Yeah, and so there are a few standard commands that you use in Linux in file system specifically. So if you see this is the file system. So now let's assume you are currently in this directory, right? Like how you do it in Windows or Mac, right? So it just got a graphical user interface. You go to a specific directory by clicking the folder, and you say all of this, right? So you just use the commands, correct? Whereas in Linux, in the shell, when I say shell is your terminal, right? So if you see, this is your terminal, this is the shell. Okay. So now in the shell, how you deal with moving from one directory to another and dealing with files, it is by using commands, and you'll have to navigate yourself to that particular respective directory, right? So in this case, there are multiple directories, subdirectories. So you go to a directory. For example, I'm right now in /Neil, right? /home /Neil. I'm right now there, and that is the current directory, right? And you will see that, right? So you will see when you work with Linux, you will see that in the Linux terminal, in the shell prompt that you get, right? The prompt is nothing but it will keep waiting for user to input at the prompt, right? So you will keep waiting at the prompt, and there you can pass the commands. In the prompt, you will see which directory you are currently, located in. And you can also use PWD, right? PW is present working directory. Okay, present working directory. You just type the command PWD and it will just tell you which directory that you are in. Okay, so once you are in nil directory, then you can actually access letter. Assume letter is another directory. You can just go to letter by saying doc/letter, cd doc/letter, or you can also use the dot, right? So the full stop. Full stop means you're always in the current directory. So if you want to run something from the current directory, then you give a full stop and slash. Okay, so that you always remember. Always, what does a period mean? Period means current directory. Or you can also use the full path. Even though you are in this directory, in this nil directory, you can still give /home/nil/doc/letter, right? So remember these three things, right? So either you can use a relative path from there, or you can use full stop, which is a period, and say /doc/letter to access the letter, or you can use a full path. So now if you see, these are some of the special file names. So in Linux, everything is a file, including a directory, right? So even directories are considered as files. So that's how the Linux file system is very efficient, because they don't differentiate between a folder and a file, right? It's just everything is a file at the end of the day. It's just the nature that it differs. It basically acts as a directory or it acts as a file. So including these, right? I mean, some of these, right? Even slash is also a file. Dot is a file, right? Everything is a file. So now some special file names are // is the root directory. This is not to be confused with the root user. Root user is different, but this is the root directory. / always / means you are in the root, which is which one? This one. So imagine root is nothing but an inverted tree. Okay, and the top of the tree is always a single point. Okay, that is called /root. So from there originates everything. Dot is current directory. Dot is the previous directory. Always a double dot is a previous directory, which means you can go to dot, or you can say dot / something, which will refer to the previous directory. Tilde, right? So tilde is always like my home directory, right? I mean, when you are logged in as your user into a Linux operating system, so when you say tilde, it means that it goes to your home directory. Home directory is nothing but, even in Windows, you have a home directory, right? It'll be in // I think some home or something like that it's called, right? So then you will have users, right? /users, I believe. C users /administrator, C users mark, right? Mark is the user who's using it. I mean, C/user/mark, and that mark folder will have like my documents, pictures, downloads, and so on and so forth, right? So similarly, in Linux also you have a home directory which has the files pertaining to that particular by default, right? So that's a default home directory. If you see here, /a, right? So again, the slash that you use, oblique, is that you use is different than Windows. In Windows, it is backslash, whereas in Linux, it is / always, right? So it's the reverse of it. So /a, it is same as a, right? So because dot means the current directory, /a is the same, the current folder that you're using, right? Similarly, /jane, which means you are moving one directory before accessing jane /x. Okay, so you are in one directory, you're going one directory back, and then accessing x is the second directory. Some special files that are there is /home, which has all the users' home directories are stored here. /bin /user/bin, it has all the system commands such as ls, whatever command that you have, everything is present here. /sbin /user/sbin, these are commands used by the system administrators. Like for example, I'm a system administrator and I've built certain utilities for managing or maintaining my system. I will store everything in /sbin, right? So that way you don't confuse with bin. Bin is the the operating system's binaries. Sbin is system admin's binaries. /etc has got all sorts of configuration files, right? So all the etc are present in the in the etc. Then /var, it stores all the logs, spool directories, everything, right? That's where it goes into logs. /dev has all the device files, right? So for example, you have mounted volumes onto your Linux operating system, right? Or you have a network interface, or you want to see what are devices that are there. You go to /dev. /proc, it contains some special system files as well. Okay, some of the basic commands in Linux, right? So let me just bring up a new Linux instance. Just give me a second. Okay, I'm just going to point you to some free online Linux that you can use. Just give me a second. Yeah. So I don't know how many of you are using Chrome as your browser. Right? So if you use Chrome as your browser, you can actually install a free extension to your Chrome. I'll just show you quickly in a minute. Okay, I'm just going to share my screen. Yeah, so if you open Chrome and you can actually Google for extensions, right? So Google Chrome extensions, and you can search for Ubuntu free online Linux server, right? I'm just going to ping this in the chat. Saram Sai Krishna, can you please make me one of the co-hosts? I'm unable to send message to the group. Or I can send it to one of the mentors, share it with the team.
Okay, sir.
Yeah. Sai Krishna, either.
Okay.
Yeah. Or
Sure.
I'll
Sure,
just
Prasan, I'll pick
ping
it up.
it
Yeah.
to. Okay, I'm just pinging you. Yeah. If you could just send it to everyone, that would be
Done.
good.
Yeah.
Okay. So once you go there, it will ask you to install this to your browser. So anyways, let me just remove it and reinstall it. Okay. So if you see this, you will get a page like this, but you have to use your Chrome. Okay. So when you use your Chrome and browse to this link, you will get this and click on this add to Chrome. It will ask you for a small confirmation. Just say add extension. Yeah. So it's added, and you will see this icon here. Under the extensions, you will see this Ubuntu free online Linux server. So just click that. Once you click that, you will get a standard list like this, and in that you select the Ubuntu, the first one, Ubuntu Genome. So just select that. Yeah. So once you are there, what it does is it actually gets you to this onworks page. So here you just click on the start. So click on the start button. If there are any ads, just close it. So what it does is it creates a new virtual instance of Linux browser based for you. Yeah. So once you get this OS started successfully and ready, okay, just say click on enter. So we'll have to wait for a few seconds.
Hello, sir.
Yeah.
Can we not make use of instances in the AWS?
EC2, you can.
Okay.
You can also use instances, but here I just wanted to show you something else also, right? So here it gives you a GUI of Ubuntu, a free GUI of Ubuntu. So this is what I was talking about, right? Most of the Linux, does not have a GUI, but this also gives you a GUI so that, you can also work with the GUI. But here, if you go here, you will get a terminal. And you will get all like Firefox, you will get here. You also get some sort of productivity, office productivity tools. Okay.
First one, the
Okay.
terminal. First
Let's
one.
give this. Sorry, where is it? Yeah, here. Yeah, just select this terminal.
So sorry to interrupt you. Due to network issue, I have your voice. After add to Chrome, what will be?
So after add to Chrome, you will get a icon like this on the right side, extensions.
Extension.
Select that extensions and click on this Ubuntu free online Linux server. And then you will get this list, select Ubuntu Genome and click on start.
Okay.
And follow the instructions from there. Yeah. Yeah. Okay. So now if you see, you have this. Let me just maximize this. Yeah. This is available. So now you can just play around with this, right? You can pass commands. Okay. It depends on your internet speed. Sometimes, it might vary. It just depends on your internet speed. But what I'll do is you can, if for those who do not want to use the EC2 or who does not have an account in AWS as yet, you can use this, but I'm just going to go provision an EC2 instance and use it. Okay. That's much more faster for the sake of this lab. Okay. So I'm here, go to EC2. Let me quickly provision an EC2. Launch an instance. Amazon Linux 2. Okay, again, if you see, I'll just go back previous. So you see, there are so many Linux versions, correct? If you see, Amazon has got its own distribution of Linux. So then there's a Red Hat, Enterprise Linux, SUSE Linux, Ubuntu, Debian, again Ubuntu, SUSE. There's also CentOS. I think CentOS is there in the marketplace, I believe. If you go to the marketplace, you can find CentOS. That's where you can see. Right, so you can get actually CentOS here. Yeah, so anyways, I'll just go back with my launching a new Linux EC2 instance. Okay, I'm just going to provision a t2.micro. Next configure instance detail. I'll put it in my public subnet. I'm sure all of you are familiar with what is a VPC, what is a public subnet, what is a private subnet, and how you connect to a Linux EC2 instance. Just going to say name my Linux EC2. Okay. And I will just use an existing security group, public EC2 SG1, which provides this one. Then launch using my KPPEM. Okay, perfect. Go to view instances. Let me select the EC2 instance. I will grab the public IP address and go to my terminal. Okay. Search -I my kppem.pem ec2-user @ okay. Okay, so now I'm not able to connect to this. Can someone tell me how should I troubleshoot this and what mistake am I making? See, I'm not able to connect to this. This is a public EC2 instance. What is the issue? What could be the issue?
Security groups.
So what is the problem with security group?
It might not have SSH protocol added in.
Okay, what else? Okay, it might not have SSH. Okay, okay, that's fine. That's a correct answer. What else? What else could be a problem?
Your system IP may not be.
My system IP may not be
Pinging.
Added in the SSH. All IC
may not be added in the SSH. Okay, great. Let me go and see what is the problem. Okay, I'll go to the security group, inbound rules. So I have 22, okay, which is there, SSH is added. But what is the IP address? My IP address which is configured here is 49.37.156.88. But let me check what is my IP. Because my IP might have changed. See, now the IP has changed 115.97.40.82. Right, so the IP address has changed. So let me do one thing. I'll just edit inbound rules. I will remove ping as well. Let me just make it 0000. Save. That's it. So now let me reconnect. Yeah, so it's able to connect. Okay, so I've connected to it. So now I have a Linux EC2 instance available for me to do my. Okay, so now let's execute a few basic commands, right? So like, as I said, ls is one of the command. What ls does is ls is called lists, right? I mean, like dir, you have dir in Windows, correct? In DOS. Similarly, ls is called list. Okay. So anyways, before that, let me just go to the root. If I want to go to root, I say cd/. Let me just. Okay, I hope it is visible. So when I say cd/, / is basically a root, correct? I mean, right now I'm in the root. So if you see this, right, this is basically your shell prompt, right? And you'll get a prompt here, right? So this is the shell through which you interact with Linux. So now you will see there's something in the square bracket, correct? What does that mean? Whatever you see in the square bracket, it basically denotes a lot of metadata about what you're currently doing, right? Ec2 user is the username, the current username that I'm logged in as. At the rate, this IP-10-0-1-140, that is called the host name. Okay, the host name is nothing but it's a name given to this computer, or it's a name given to this virtual machine, like how all of us give some names to our Windows machines, correct? So host name, even if you go to Windows and type host name, you will get the host name. Okay, so if you see, this is the host name, IP-10-0-1140. Anything after the dot is basically the fully qualified host name. Forget about that, but this will only give the primary host name, which is IP-10. So that's called the host name. You can also try this in your Windows computers. I think command, if you go to open a new CMD and type host name, you will see the host name. Okay, and then after that, you get a space. After the space, you get this one, right? You get either a slash or a tilde or some sort of a path that you see there, right? That is your current working directory, which is called PWD. So that's where you use PWD. When you say PWD and enter, you will get this slash, which means you are in the root. That's called PWD. Then you close the, then the square bracket is closed, right? So then you have $. Dollar basically means that you're in the bash. So bash is basically a terminal interface that Linux usually uses. So that's how you see this. So this standard thing that you will see in most of the Linux distribution, and you can also customize it through some way. Anyways, I mean, so this is how you see in actually in Ec2 instance, right? So now I will say ls, right? So now this gives me, it lists all the contents of this directory. My root is / and I'm just saying ls. Okay, so now I want to basically make my ls more intuitive, right? So now you can say man, right? So man is manual, correct? Man ls, it'll tell you, it'll basically list the entire user manual for ls command, along with all the flags and all the arguments that you can pass to the ls command, right? So you can just read about it. Just say q, it quits. So now what you can do is ls-l will list the whole thing in a nice format, right? With more details and more information. So right now it was like listing it in a complete, something like a comma separated value, or it's a continuous list, but here it's more of a more detailed list, correct? So it tells me what is the file permissions that the particular file has, correct? And who's owning it, right? Root is basically the user, right? So root is the user who's owning it. So it tells me what date and what was the file size. It tells me when it was last modified, the time. Then it tells me what is the file name, right? Imagine, remember, even folders are represented as files in Linux. Okay, it tells me what is the file name. Folder is just a special type of file which can hold more files. That's it. That's the way you have to look at it. Okay, so as I said, it has been, it points to user bin, right? Lib is libraries, it has libraries. So then it has /user/var, right? /dev, like /dev is where the devices are found, right? If you want to go to say if you want to go to devices, so right now you are in root, right? So which is /. So now from root, you want to go to devices, correct? Now devices dev is in root only. So either you can do cd dev, it will take you to dev. So now if you see, it suddenly changes to dev, or if you want to go to the root again, say cd/, or you can also do cd/dev. It will also take you to dev. Okay, again, I'll go back to root. I can also do cd/dev. It will take me to dev. So this is what we were looking at here, right? In one of these slides. Yeah, see, you can either do it from a relative location, or you can do it from the current location, which is dot, or you can do it from the full path. Okay, so that's how it works. So now, right now, I'm in dev. How do I know I'm in dev? There are two ways that you can know that. It will show here which folder you are currently in, or you can say pwd, which means it will say /dev. Okay, so that's where it gives you, this one. Now I can go to cd/home. cd/home is another directory which contains the home directory, right? Home directory of all the users. Okay, that's what cd/home. So here I can give ls-l. It tells me how many users are there, how many users folders are stored in the home directory, and say cd ec2. Okay, there's one more advantage than Linux is you can say cd ec and say tab, it will auto complete it. If there are multiple ec2 hyphen with similar name, then it will list down only those filtered files, and then you can pick up one from that, right? So it will make your job more efficient. In fact, that's one reason why a lot of administrators prefer to use Linux commands, because sending commands and working with commands in Linux shell is fun, and it's a lot more easier, right? Than using a graphical user interface. If you have to use the graphical user interface, then it becomes a little tedious to basically navigate through using mouse, right? So using keyboard is a lot more easier than using mouse, right? So yeah, from a user experience standpoint, I mean, aesthetically using mouse is a lot more aesthetic, whereas if you from a user experience standpoint, from a productivity standpoint, your productivity will be much higher if you use a Windows terminal. I mean, not only that, I mean, Linux, the kernel of the Linux, right, which is the core of Linux, is very, very lightweight in nature, and it's so efficient. The memory management, the resource management. When I say resource management, the CPU and memory management in Linux is so efficient that it basically gives you a better environment to build and run your applications. Okay, so that's the reason many organizations use Linux or Unix based operating systems to build to host applications on it, right? Even if they've built say Windows .NET application, right? The Microsoft .NET application, .NET applications can also run on Linux, but you just need to use a version of .NET called Core. You have to convert your .NET applications into Core, or you have to use a framework in .NET called .NET Core. Start building your application and host it on Linux. You just need to install the core .NET Core packages in Linux and start using it, right? So that way it makes it a lot more resource efficient, and administrators get a lot of flexibility in terms of using the shell, and its the productivity increases. And not only that, I mean, a lot of automation is possible in Linux through the shell that you have. Shell scripting, initially people started using shell scripting. Shell scripting is nothing but a PowerShell, right? I don't know how many of you know what a PowerShell is. Windows later on Microsoft came up with a shell scripting language similar to Linux. It's called PowerShell. PowerShell is also quite famous, and it is used in the Windows Microsoft world. Whereas in Linux, shell scripts are quite familiar and popular with a lot of administrators. So that way, it becomes very, very easy and faster for administrators to use this shell. Okay, so now let's go back. So now if you see, this is the command that I'm passing, -l /etc. This is the probably I want to list down what is there in APC, right? /etc. I can do ls -l /etc. It will list down whatever is there in /etc. But I'm right now in which folder? I'm right now in EC2 user folder, right? Yeah, I'm right now in EC2 user folder because you see tilde. Tilde means that's my home directory, which is /home/EC2 user. Right? So that's why tilde is there. Okay, but I'm able to list down what is there in /etc. Okay, or I can do /bin. Okay, or I can do /user/bin. Yeah, it will list down all the commands that are there in Linux. So the /user/bin has got all the commands. Like for example, ls is a command by itself, right? There is lsc. ls is here. Okay, it is 1,09,288 bytes. That's the length of the ls command. Yeah, and so then you have so many other commands that you have there, right? So all these commands are part of the Linux kernel itself. So when you say clear, it clears the entire screen. Okay, let's move on with our subsequent commands. I'm going to just skip this. Okay, you know what? You can also send a pipe, right? You can use a pipe. Like for example, ls-l will list down everything on the screen. But what if you want to send it to a file? That's where you can use this pipe. Okay, greater than symbol will be, there is a pipe concept in Linux. So if you see, I'm right now in my /home/EC2 user, but I want to go to cd/etc and I'll say ls-l. So it has all the files and folders present in ls-l. So now let me just clear the screen and I will say ls-l greater than /home/EC2 user /output.txt, right? So when I say /output/txt, it'll just take all the output of ls-l into this particular file /output/txt. So now let me go to it. It will not display anything on screen. Then I'll go to /home/EC2 user and I'll do an ls-l. You'll see this /output.txt. Okay, so now how do I see what is there in output.txt? So you can use a command called cat. Cat output.txt will list down the contents of a file on the screen, right? So now this, or you can use a editor such as vi output.txt. So now this is a vi editor. It lists, it's like a text editor, right? Notepad in your Windows. So it just gives, and vi is good, right? I mean, I love vi because of the flexibility that it gives, but some people, get a little overwhelmed with the commands that vi offers. So there's also an editor called nano. Nano is also powerful, simpler to use. So see, the contents of this output.txt contains the actual command execution output, correct? So when I say ls-l, that presented something in the screen, on the screen, right? So all that is redirected to a file. Okay, I can also do something like this, right? I can say I can create a new file, right? So using vi. Okay, let's come back to that. But in the meantime, let's just go here. This is redirecting the output. You can read some input for the command from using a less than symbol, right? So which means that input is being passed to this command. So in the previous one, The output of ls-l was sent to this output file. In this case, there's a file that is already existing, which has something in it. This is passed into this program. See, WC is basically a word count. Okay, it's a command that is used in Linux to word count. See, WC. So now let me see if I go to which folder am I in? I'm in output.txt. I'm in pwd/home/ac2 user, right? So now I can see WC less than output.txt. It will count, how many words are there in the output.txt. It will tell me this output. Okay. WC is nothing but a word count, right? I'm sure all of you would have done in your C++ lab, right? Word count. That you would have built a small word count utility by yourself using recursion and using say some of the data structures, correct? Okay, let me go back. So this is how you use a input into a command. Again, pipes, right? So pipes are the way to combine multiple commands into a single command. Okay, so in this case, the output of another command becomes the input of another command, and then this output goes into this input. Okay, so that's how. So now if you see here, sorry, it's the other way around, right? So the output of PS command is sent to grep. So then the grep takes inputs and searches for Netscape, passing these lines to word count. Then it sends it to word count -l, right? So that way your PS AUX is a command that is used to list down all the processes that are running. So in Windows, what you do, you go to task manager and you check the process, right? Whereas in Linux, you use PS -AUX. It will list down all the processes that are running on my Linux operating system. Okay, so now from within this, I want to know, I want to filter only the process which has crony D in it. Okay, I want to basically take this, right? So let me just copy this crony D. So I will say PS-AUX, then I will put a pipe symbol. So then what I'll do is I'll say grep. So grep is another command which is used to search from within a stream of string or stream of characters, right? So that's called grep, right? So grep is a very famous and powerful command that Linux has. Right? So even a lot of editors, for example, like editor called Epsilon, used to be one of my favorite text editors. Epsilon was used in Windows and even Linux as an Epsilon. You can run some powerful grep and using some regular expressions. How many of you know what a regular expression is? Regex. Regular expression is used quite frequently in programming, right? In Python, regular expression is used. Regular expression is used in multiple places, right? So if you build a C++ program or C#, you can use a regular expression. Anyways, I'm going to grep for crony D, right? And then I'm going to say, then WC takes this input and counts the lines, its output going to the console, right? And I'll say WC-L. See, there are two lines with the output that has crony D. Okay, let's just verify that. PS-AUX. See, there's one I found somewhere here. Crony D is here. Okay, the other one. Okay, you may be wondering what is the other one, right? So now the other one also is, see, for example, when you're running PS-AUX, that command itself is a process for Linux, right? That is also listed here. So now when I say PS-AUX grep, pipe grep crony D, you will also see that in the the list of processes that are running, and then it will go away. Once it runs, it goes away. So that's how powerful Linux says, right? So it has two lines, that says cronid, because one is used by me to grep cronid. The other one is the actual cronid which is running, the cronid daemon which is running, okay, which is running under the user called cronid, right? So that's how you can make use of. See, if you want to see how many Netscape are running, you can do, or you can say cronid, or it can be as simple as SSHD, right? SSHD is very common, right? So use SSHD. So any Linux terminal will have SSHD running. See, there are like 3 running, or 4th one, which is this command itself. Now I can do wc-l, it will show 4 as the output. Okay, then you will have command options -l or -help, right? So these are some of the common commands: present working directory, cd change directory, ls list the files, ls-l in a long format, right? List the files in the current working directory in a long format, which means it has so many other details embedded in it. Some other common important Linux commands are ls cp is you copy the file from source to destination, move a file from source to destination, right? If you want to just say rename a file, right, you can just use move. For example, I'm here in my home directory. I want to rename output.txt to output1.txt. I can say move output.txt to output1.txt. It will simply rename the file. It will move the file. That's it. To this one. Okay. So then I go back. Yeah, VI is a file editor. Chmod. Okay. Chmod is again another important command that you use in the context of, again, EC2 instances that we're dealing with. Chmod will help you with changing the file permissions, right? So, but before that, you need to understand what are the file permissions, right? So how file permissions are managed, right? So I'll come to that in a bit. It'll take about 5-10 minutes to explain those concepts. So then you have mkdir, rmdir. So these are all commands to modify the directories, right? So rmdir will remove the complete directory. Rm is removing a file, right? So you can remove a complete directory tree by using rm-rf and giving the path, right? So file path. cd is to change directory. So some commands in networking, telnet is a command that you can use. I think I showed you the telnet the other day. Ping is a command that you can use. FTP, who, right? I mean, who will actually tell you who else is logged in, right? Just say who, right? So I'm logged in as EC2 user. It will list down all the users who are logged in. So I'm logged in from this IP address. That's my IP address, right? Yeah, then these are all commands to manipulate the files. Cat, you can concatenate. Cat will basically list down the contents of the file. More, less. Again, less is a file you can use to scroll through page by page, right? So then tail is a command that you can use. Commonly, it is used while you're troubleshooting, say, log files, right? You can say tail -f, and you will say some log, right? Tomcat.log, and it will keep printing as and when the log file will get some entries into it. It'll print that on the screen. It'll just keep scrolling. Word count, and these are some of the commands that you can just you use for manipulating the files. Since I'm not going to go deep into this command, I'll leave it to your personal learning of these commands. I'm going to give you this PPT, and you can go through these commands. You can experiment with these commands, right? I mean, more importantly, you experiment it. These are some of the file commands that you can use. cp from file to to file, move from file to file, rm file, right? When you say rm, it will delete that file, right? So I'm just going to cp output.output2.txt ls-l. So now I'll say rm output1.txt. It would have deleted that file, right? Similarly, mkdir, you can create a new directory, mkdir new dir. Yeah, new dir is created, and rmdir, rmdir, newdir. Yeah, it deleted the directory. Okay, I just, by my finger memory, I just typed LL, right? LL is nothing but it doesn't come by default, but you can create alias in your terminal to say that when instead of pressing ls-l every time, you can actually create an alias to convert this ls-l into ll or ll into ls-l by default, right? So you can create an alias. You can browse, you can just go to Google and say create alias for Linux commands, and you will know how to do that.
phone cheyadi.
Please go on mute. SB67, please go on mute. Okay. Then echo is, you want to echo a string, you can just use echo. Alias, right? I was just telling you, alias, you can use this alias command. Okay, chown, you can change the ownership of a file from one user to another user. Find is another command to search a particular file in the entire file system. Okay, grep, you can use one or more pattern within grep. Kill is to kill a particular process. Okay, you can kill your own process unless you are the root. Right? So when you say kill process ID, this is a process ID 6715. So if you say kill, it just kills that process. Okay. Anyways, I mean, there's so much of learning in Linux, but I'm just going to go very quick into some of environment variables. I'm going to skip. These are some of the things that you can do. Path. I'm sure all of you who know Java, you know what path is. You can set a path, right? So you can set a path in Linux, and it's an environment variable in Linux. So by default, you don't have to keep referring to the full file name. All the folders that are listed in the path will be searched when you run a command. So if the command is present in one of these folders, it'll get executed. Okay. Yeah. Okay. All right. Let me come to file permissions. Right. Okay. Every file, including a folder, is owned by someone, and it belongs to a group. Okay. And it has certain access permissions for its owner, for the group, and for others, right? So that's how permissions are designed in Linux. How it is designed, there are three groups who can access permissions or access files or deal with file permissions. The first one is myself and the group that I belong to. In Linux, you can create groups, right? You can create groups and you can map users to a specific group. Okay, group is nothing but it's like, for example, right? I have a Linux system. I have multiple departments in my company. Sales is one department, finance is one department, HR is one department. Okay, development is one department, testing is one department. So 5 departments, right? So each group 5 groups can be created and users can be assigned to each one of these groups. Owner is a user, group is a group of users, and others is any others, right? So who may come in as a guest user or anyone else, right? Anyone else other than any of these would be others. Okay, so that's how every file is given permissions, right? So now there's a user ID that is it. So this you are a name or a number, right? User ID. And group ID will have a group, usually normally the group that you belong to. Okay, if you say groups list, you can actually access via group permissions. So now that's how there are 3. Remember, it is the user, the group, and others. User, group, and others. So these are the 3 broad level of I would say permission boundaries that can be created. Okay, so now what are the actual permissions that a folder or a file can have? There are 3 permissions that a folder or a file can have, which is read, write, and execute. RWX. Okay, execute is represented as X, R, W, and X. Okay, read is users with read permission may read the file or list the directory. Users with write permission may write to the file or new files to the directory. Execute, users with execute permissions may execute the file, right? So because again, at the end of the day, a file can be either a simple text file or it can also be a binary file. But the difference between a simple text file and a binary file is that text file just contains some text string into it, right? Text content into it. Whereas a file with execute permission is a binary file which will execute the command, right? Like how you have .exe in Windows, correct? What is .exe? Exe is a executable file in Windows, correct? So only if a file has .exe for exe extension, it will be able to execute commands. So similarly in Linux, only if a file has got a execute permissions, you will be able to execute the file. Okay, so now how the file permissions are, managed, right? So if you see here, so this is the first column, right? So when you do ls-l, this is how it will be displayed, correct? This is the first column that where you see the permissions. I'll come to this. Okay, for now, just leave it. Okay, so then comes the owner. Okay, after that, you'll see a number. Forget about this also. So then you will see one owner. So this is the user name, who is owning this file. Like, for example, you have hello.c, hello.x, POSIX, right? So these are all files in Linux. So now this file is owned by this user. Okay, and then the one that follows, the next column that follows is the group who owns this file. Okay, in this case, the group also has the same name, but it's a group, RVDHEIJ. Okay, so then comes another column. This is a number. I mean, it's ignore it for now, but that's the file size. So then comes the timestamp. Okay, the timestamp of when the file got modified or created. So then the actual file name. Okay, this permissions owner, this is the group. Okay, so now let me go to terminal. I will say ls-l. So you see this, the first column is the permission. Forget about this. This is the ec2-user is the username, and this is the group name. ec2-user-user is a group also. Because it's one-to-one mapped. So this is the size of the file. This is the timestamp when it got created or modified, and this is the file name. Okay. Now let us double click on this permission part. So this is the permission, correct? This one. You see -rw, -rw, -r, What does this mean? Okay, let's see what does that mean. Okay, so now this is what you see, right? Okay, so now this is split as 10 characters. Okay, this entire thing that you see here is split as 10 characters, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has 10 characters in it, right? So what does those 10 characters represent? The first one, when you say hyphen, okay, it means that it's a file. If it is a directory, then you will say D here. If it is a link, in Linux, you can create a link, right? You can create a link. For example, when we went into cd/ and said ls-l, this is bin is linked to user/bin, right? So actually the physical path is user/bin, but I'm just creating a shortcut to that. It's like a link, right? So when you create a folder and you can send a link of that folder on your desktop so that you can access it frequently, right? So that way you just link it, it's hyperlinked to that particular physical location. So that's why if you see, it's a link. When you say L, when you get L, it means it's a link. When you get D as the first character, it means it's a directory, right? When you have hyphen in it, it's a file. So that's how it is represented. So remember, always hyphen means it's a file, D means it's a directory, L means it's a link. Okay, so then comes the permissions. Okay, the first, the second, third, and fourth characters that you see is read, write, execute, which is the owner permission. So then the next three characters is RWX, that belongs to the group permissions. Then the third, last three, 8, 9, 10 belongs to other permissions. Okay, this is the owner himself. This is the group that the owner belongs to. The last three characters are others. It could be any other users. It could be a guest user who's coming from outside, or it could be an unauthenticated user who's coming from outside. Right. So now let us go and see what it means. Right. So here, if you see boot, right? So boot is a folder that you have. So now it's a directory, and the boot belongs to root. Okay, belongs to root. So now, if you see this, let me take this in a notepad and explain this better. Okay, I'm just taking it here. So this is the output of this, right? So in this case, D means it's a directory. Okay, and then you have R-X. Okay, so now the user who's owning this is root, and the group which is where root is part of is also root. Okay, now the first three characters out after this, which is the second, third, fourth, right? So the first one is D. So now second, third, fourth. Okay, this is the user himself, correct? User. So second is a read, third is nothing. When you say hyphen, there's nothing, no permission is given. Okay, and then fourth is X, right? So when ideally in third position, you should have had W, read, write, and execute. Now the root user does not have write permissions. The root user only has read and execute. Okay, so similarly, the next three characters are 5, 6, and 7, correct? 5, 6, and 7, which again is similar. Read, no permissions for write, and it has permissions to execute. So that is for group. Then the last set is 8, 9, and 10. Again, it has read, no write, and execute permission, which is for others, all others. Okay, so this is how you manipulate the file permissions, right? So this is how you read the file permissions in Linux. Okay, and then you can use chmod. Okay, you can use chmod to change the file permissions. Okay, so now chmod has got a lot of different variants to change the file permissions. I mean, you can actually use an octal number to what is octal, right? What is one octet? It is 8 bits, correct? So you can use an octal number, the representation of a bit of a byte as a decimal, right? So that's called an octal number, to change the file permissions in chmod. Okay, so now how do you change the file permissions in chmod? I'll just come to that. If you just go to Google and go to say chmod exam tutorial, okay, you will get this multiple tutorials. You can just, so in fact, if you remember, I changed the permission of the key file from using chmod 400 PEM file, correct? So now that's, yeah. Okay, so now 4, 2, and 1, right? So that's how these are the octal numbers, right? So what are the octal digits? It's 0 to 7, right? 0, 1, 2, 3, 4, 5, 6, 7. It's just 8, right? So that's the 8 bits, right? It's 1 byte basically. So it's derived by adding up the bits with values 4 to 1, right? So now 4 means read, 2 means write, 1 means execute, which means a total of 7. Okay, so now what I can do is let me go to my root directory, home directory, and I'll say ls-l. So now this is a file, and EC2 user is the user who has read, write, but no execute permissions. EC2 user group has read, write, no execute. Others have only read permission. So now I want to change this. Okay, so I can say chmod. I can say 7. I want to get full access to only myself. I don't want access to others. Then I'll make it 0, 0. So remember, 7 is full permissions, which is comprising of 4 for read, 2 for write, and 1 for execute. So 4 plus 2 plus 1 is 7, correct? So that way I'm giving full permissions to myself, no permissions to group and others, which means this is group, this is others. Okay, third one is others. So chmod 700 output 2.txt. So now let's see what is the permission. See, if you see, only I have full access, no one else has got access to it. Okay, so now I can change it chmod 770 output.txt. Now I have given full access to my group, no access to others. I can say chmod 777 output.txt. All access to everyone, all full access to me, full access to group, full access to others as well. So now let me change it a little more, right? I will say chmod 4 to 1 output.txt. What will be this output? If you see, I have 4, right? So which is 4 is nothing but read, 2 is write, and 1 is execute. So I have given read to myself, no read to group, right? And no execute to group, only write to group, and only execute to others, right? So you can create something like this, like permutations, combinations. Now I don't want to give any user any permissions to others. I want to just give only read permissions to myself. Okay, then I'll say chmod 400. So now if you see, chmod 400 is only read permission to myself, no permission to write, no permission to execute to even myself and others, right? So this will be the minimum permissions that you can give to a file, which is chmod 400 output 2.txt. So now the key that you use, the PEM file that you use, has to be secure, right? So that is the reason why you secure that PEM file, so that no one else will be able to use it. And even the current user who is logged in, or the owner of the file, can only read it. He won't be able to edit the file or tamper with it, right? So for example, I have only read permission, right? So now let me try to edit this file. I'll say nano output.txt. You see here, you get an error saying that file output.txt is unwritable. You won't be able to make any changes to this file. Okay, and you won't be able to save it, right? So when I say come out of it and say, it will not allow me to save the file because permission is denied. So I just have to come out by discarding all the changes. Okay, so now this is how file permissions work in Linux, right? So now it's very important you learn this and understand this. So what I'm going to give is, I'm just going to give you some lab sessions for today. I'm just going to share the assignment document with Brother Murli. I'll send it to you. You can share it with others.
Sure. Yeah.
Excuse me, sir.
Yeah.
Sir, if you want to further learn Linux, then what are the steps we should take?
Okay, you'll have to. There are some self-paced trainings that are available. I will share those with you later. Okay, I'll figure out which one is the best one. I don't remember on top of my mind at this point in time, but I'll send it to you.
Thank you very much.
Okay, I'm actually sending you 2 files. One is the assignment for today. The other one is this PPT that I just shared with you, or I just used for explaining the concepts today. Yeah, I've sent both these files. One is the assignment for today, which has the files that you want to, the commands that you want to try out today. The other one is the PPT that I just explained. Okay. So please, do this. And as I said, just set up that small Chrome extension and you'll be able to use that Chrome extension and make use of. Okay. And I've also put a link in the PPT for Chmod. It's a blog article from Geeks for Geeks, which has the Chmod, and you can learn more about Chmod. But I believe you are now familiar with how Chmod works and why did we use Chmod 400 to secure our PEM key file. Okay, so I will just take leave from here. I've got a hard stop now, but I'm sure you'll be able to get into your lab sessions and start doing these exercises. And I believe this is a good kind of a Kickstarter for you to learn Linux further. I'm going to give you some self-paced trainings for Linux for those of you who want to dive deep into Linux, right, and learn more about Linux. And yeah, thank you so much. I will see you all again tomorrow morning at 8:30, and we'll start with Knackles, which is another important topic in VPC. Okay, and let's continue from there on our AWS. Okay, so thank you so much, and have you all got a nice day. And thanks, mentors. Saram. Bye.
Thank you, sir.
Thank you.
Thank
Bye.
you. Thank you so much.
Thank you.
Bye.
Saramana, thank you so much. Guys, I'm just, yes. Okay, we'll just go into breakout room sessions and then we'll discuss about today's topic. If you guys have any questions, just park it with your mentor, and if they can able to solve, well and good. Let's not will save us for tomorrow.
Thank you, Kish.
Sure, just join the breakout rooms, guys.
Hello, Chris brother. Hello,
Yes.
bro. Once again, send me the request of Teams.
Okay.
Thank you. Thank you, bro.
Yeah. Vijay bro, I sent you there as well. Basha, can you join to breakout room number 6? And do I need to repeat every day, to change your name back to student ID? Mr. Basha, can you hear us? SB91, SB61, can you join your breakout rooms, please? Hi, Pawan Kumar. Are you
Hi.
joining for the first time or?
Yeah,